Human history is often described as a story of continuous progress. We imagine knowledge as something that accumulates, step by step, until it builds the modern world around us. But in reality, history is far less linear. Civilizations rise and fall, wars and crises interrupt cultural traditions, and with them, entire crafts and technologies can vanish. Some are lost for centuries, only to be rediscovered later through trial, experiment, or archaeology. The story of lost and rediscovered technologies is not just fascinating, it reminds us how fragile progress really is. One of the most famous examples is Roman concrete. The Romans mastered a building material unlike anything else in the ancient world. Their recipe combined volcanic ash, lime, and seawater to create a substance that actually grew stronger with time. Tiny crystals would form inside cracks, sealing them and preventing decay. Thanks to this, many Roman structures, aqueducts, harbors, and even the dome of the Pantheon still stand after 2,000 years. But when the empire collapsed, the knowledge of this concrete disappeared. Europe returned to weaker materials like simple stone and mortar. Only in the 19th century did modern concrete, based on Portland cement, emerge. Today, scientists once again study Roman concrete, hoping to apply its secrets to build structures that last longer and have a smaller environmental impact. Another example is Damascus steel, legendary in the Middle Ages. Swords forged from this material were said to cut silk in midair and shatter weaker blades. They combined strength, resilience, and razor sharpness with a distinctive, wavy surface pattern. This steel was created from a type of high-carbon metal called woods, imported from India and worked with careful heating and forging techniques. By the 18th century, however, the supply of raw materials declined, and the secret methods were forgotten. For centuries, craftsmen tried to recreate Damascus steel, but with little success. Even modern metallurgists still debate how exactly the original process worked. While similar alloys can now be made, the aura of mystery around Damascus steel remains. In the Byzantine Empire, another legendary technology was Greek fire. First used in the 7th century, it was a terrifying weapon. A burning liquid that could ignite on water and cling to ships. It was projected through bronze tubes mounted on warships, and it helped save Constantinople during multiple sieges. The exact composition of Greek fire was a closely guarded state secret, and when the empire fell, the knowledge was lost. Historians and chemists still speculate about its ingredients, perhaps petroleum, pine resin, sulfur, or quicklime. Yet no modern formula has perfectly reproduced its reported properties. Greek fire is a reminder that some of history's most advanced technologies can vanish completely. Water management offers another striking case. Roman aqueducts carried fresh water across vast distances using arches, tunnels, and pipes. These systems supplied cities with fountains, baths, and sanitation on a scale unmatched for over 1,000 years. After the fall of Rome, such infrastructure decayed. Medieval towns in Europe often lacked clean water, leading to poor hygiene and frequent outbreaks of disease. Only in the Renaissance, and especially in the modern era, did large-scale water systems return. The interruption shows how a sophisticated technology can vanish, leaving entire societies worse off for centuries. In the Gothic cathedrals of medieval Europe, stained glass reached an artistic and technical peak. Windows glowed with colors so deep and luminous that they still inspire awe today. The rich sapphire blue of Chartres Cathedral or the ruby red glasses of other churches were produced by careful mixing of metal oxides and complex firing processes. Yet by the late Middle Ages, many of these techniques were forgotten. 19th century craftsmen during the Gothic revival tried to replicate them, but even today some medieval shades cannot be perfectly reproduced. The lost recipes of stained glass reveal how fragile artistic technologies can be when traditions are broken. Even the basic materials of writing have been vulnerable. In antiquity, skilled artisans produced durable parchment and stable inks that could survive millennia. Some Roman and early medieval manuscripts still display dark, clear writing thanks to iron gall ink mixed with tannins. But over time, knowledge of more resilient formulas weakened, and many later inks faded or corroded the page. Only through modern study of surviving manuscripts have researchers been able to reconstruct older methods of making ink and parchment. What seems simple, writing on a page, is in fact a fragile technology shaped by centuries of trial and error. Ceramics and glass tell similar stories. Chinese porcelain astonished Europeans for centuries. Its translucence, hardness, and delicacy. The story of lost technologies is not limited to the most famous cases of Roman concrete or Damascus steel. There are countless smaller, lesser-known examples that illustrate the same principle. Knowledge can vanish when social, political, or economic circumstances change. By exploring more of these examples, we can gain a richer understanding of how fragile human progress has always been. Consider, for instance, the art of purple dye in antiquity. Known as Tyrian purple, it was extracted from sea snails and prized across the Mediterranean for its rich, lasting color. This dye was associated with royalty and imperial power, and for centuries it was a symbol of wealth. The process of producing it was difficult, requiring enormous quantities of mollusks and painstaking labor. With the fall of the Roman Empire and the decline of trade routes, the knowledge and infrastructure needed to produce Tyrian purple disappeared from Europe. For over 1,000 years, it was impossible to reproduce. Only in modern times have chemists analyzed ancient textiles and identified the compounds responsible for the color, allowing partial reconstructions. Another fascinating case is the knowledge of hydraulic engineering beyond Rome. In Mesopotamia and Persia, ancient engineers built qanats, underground channels that transported water across arid landscapes. These tunnels, dug by hand and maintained over centuries, sustained agriculture in desert regions. While some qanats survived, many fell into disrepair after invasions, shifts in population, and changes in political systems. Today, some are being restored, but much of the practical knowledge about their construction and long-term maintenance was lost. This is an example not of a single invention, but of a sustainable system of water management that faded with time. The same can be said of large-scale urban heating systems. The Romans used hypocausts, underfloor heating systems powered by furnaces. Public baths and wealthy homes could be heated evenly, a remarkable comfort for the ancient world. After Rome collapsed, this technology vanished in Europe. For centuries, medieval people relied on open fires and primitive stoves. Only much later did radiant heating and similar systems reappear, demonstrating how everyday comforts can vanish when cultural continuity is broken. Glassmaking offers multiple examples of lost skills. Beyond stained glass, there is the mysterious dichroic glass used in the famous Lycurgus cup, a Roman artifact that changes color depending on the angle of the light. It appears green in reflected light and red when light passes through it. This effect is caused by tiny particles of gold and silver embedded in the glass, a form of nanotechnology created by ancient artisans who could not have understood it in scientific terms. After the Roman era, such techniques were forgotten, and the ability to make glass with these optical properties disappeared. Only in recent decades have scientists studied and recreated the phenomenon. Another lost art was the making of flexible glass, or vitrum flexile, a substance described in Roman sources. According to legend, a craftsman brought a vessel of flexible glass to Emperor Tiberius. The vessel could bend without breaking, and the emperor, fearing the collapse of gold and silver markets, ordered the craftsman executed to keep the secret from spreading. Whether this story is true or not, it reflects the idea that remarkable materials may have existed and then vanished entirely. Paper, so common today, also has a history of loss and rediscovery. The Chinese invented paper making in the 2nd century BCE, but it took centuries for the technique to spread. When it reached the Islamic world, paper mills flourished. But in Europe, parchment and vellum remained dominant until the Middle Ages. The Mongol invasions, wars, and the collapse of certain trade routes interrupted the spread of paper in some regions. When it finally returned to prominence in Europe, it sparked revolutions in literacy and printing. The delay shows how fragile the transmission of a single technology can be. Lost technologies also appear in the field of food and agriculture. Roman garum, a fermented fish sauce, was a staple condiment in ancient cuisine. Its production involved complex fermentation processes that gave it a unique flavor. With the fall of Rome, large-scale garum production ceased and the taste was lost. Only recently have archaeologists and experimental chefs attempted to reconstruct it, revealing how even something as ordinary as a condiment can vanish for centuries. Similarly, ancient methods of grain storage, underground silos that preserve crops without spoilage, were once widespread but largely forgotten until modern archaeology rediscovered them. Medicine, too, contains examples of lost practices. Ancient surgeons in India and the Mediterranean world developed techniques such as cataract surgery and advanced herbal remedies,